Wow, thank you so much, Dan. That was just an absolutely fascinating tour, and you've still left plenty on the table for us to read about in your book in the later chapters as well. So thank you so much for that. I think I was just talking about personalized medicine. Just the potential of it seems phenomenal. Yes. Whereas I just thought it would just be sort of, maybe you get your DNA sequenced and then your doctor would have that.
I think Martin, that we're going, things are going to explode in that. And it's not just gene sequences that we're talking about. I think, for example, there's an analysis of your microbiome, which is essentially the bacteria that are found in your stool, the gut microbiome. At the moment, it's known that the contents of your gut microbiome correlates with lots of different things, and we don't yet really, to be honest, really understand that. But there's no question that it's going to be informative in the future, and in many ways. And just to give you two examples. In diet, lots of people are on dietary plans, eat more of this, less of that. And it turns out that in truth, what works well for someone may or may not work well for someone else, because a diet that works is a very personal thing. And it turns out that with a big data analysis of what things may or may not correlate with what foods cause a sugar spike, for example, which might be considered to be a bad thing, then it's very personal, and it correlates with the component, the bacteria components in your gut, in your stool. So an analysis of microbiome might indicate, for example, what diet is going to work well for you. We also know that in cancer treatments, there's some evidence that, there are certain immune therapies, so a treatment that boosts your immune cells to fight your cancer, but then only works for a certain number of people, certainly not everyone. And one of the things that correlates with whether or not it might work is, in fact, the contents of your microbiome, which is bizarre, but your microbiome is actually intimately entwined with the state of your immune system. So there's essentially, what I'm saying is that it's not just going to be down to genes. It's going to be down to, as I've given the example of the microbiome, but there are many, many other things. In your blood are circulating bits of DNA outside cells. In your blood are packets of proteins and genetic material called exosomes. All of these things could feasibly be used as diagnostics of your state of health. And I think that we're going to get into a world that is very difficult to navigate, really. Famously, Angelina Jolie had two breasts removed when she learned that she was essentially 87%, given an 87% chance of developing breast cancer on account of having a family history and a mutation in BRCA1. But that's a relatively clear-cut situation, at least. You can make a decision based on 87% chance. That's quite high. But a lot of the other information that you might be able to access is much, much more fuzzy than that. And then what would you do? What would you do if you had a 1 in 4 chance of getting cancer over the next 20 years, or a 1 in 6 chance over the next 5 years? It's very, very, very difficult. And you have to balance these difficult risks with also the risks of what the solution is. If it's surgery, for example, that carries its own risks and problems. So I think we're going to be deeply affected by this new biology, both in a sense of understanding what we are, but also practically in the way that healthcare throws up all these very difficult things for us to emotionally deal with.
Yeah, you're absolutely right. It's not just going to be a case of us, sitting back and accepting these new treatments, but like you say, being confronted with probabilities and statistics and being told, well, if we do this, there's this, and if that, then that. Like you say, it's really important that we sort of get a grips with these kind of technologies right now, so we're kind of a bit prepared for these kind of ethical questions that they're going to throw up. Anyways, enough of me chatting. I've got a whole load of really good questions. If you haven't already asked a question, do jump into the chat. We've had quite a few from Garth, so thank you so much, Garth. You've asked a load of really good questions, but I don't want to just feature Garth's questions. So if anyone else out there has questions, do drop them in the chat. But I'll kick off with a few that Garth's asked. Which also,
can I just say, maybe add in the chat if Spain or Italy score. Thanks.
So Garth was asking about the super resolution optical microscopy and how it kind of compares with some of the other high resolution techniques, electron microscopy, X-ray diffraction imaging, like you get in the diamond light source or whatever. And when would you use one over the other?
Yeah. So that's a great question. In fact, one of the things about those other types of microscopy you just mentioned is that, so for example, electron microscope, the sample has to be treated in a certain way, embedded in chemicals and put in a vacuum. So you can't look at a live cell. With a light microscope, you can look at a live cell in its own state. But as it happens, no technology is perfect. So what we have is a series of different kinds of technology, because I actually glossed over some of the details about the different kinds of super resolution microscope that there are. And as well as that, there's an electron microscope, as you mentioned. And each type of instrument gives you a view of the body within a certain way. So for example, one type of microscope might be really good at resolving down to single individual proteins in the cell. But the problem is that kind of microscope can't then see the proteins moving, because it takes a time to build up this image of all the individual proteins. So you don't have time to see where they're moving to. So you use a different type of microscope to see the movement of molecules. But then when you look at the movement of molecules, that type of microscope doesn't have quite as good spatial resolution. And then you need a different type of microscope to look at a bigger field of view. So I might want to look at how lots of cells are bumping around and interacting with each other. So depending on what I'm doing in the science, depending what the question is, depending what my experiment is, I would need to use a different type of microscope suited to addressing that question. Or even if you're using microscopes in a very explorative way, just to look at stuff and see what it looks like, each type of microscope will show you a view, but it's not the whole view. Actually, in the book, I liken this to, if you look at the iris of the Mona Lisa in great detail, it doesn't tell you much about the Mona Lisa. And in fact, even if you look at the whole of the Mona Lisa, it doesn't tell you about the Mona Lisa, because, for example, there are other things like the value of the painting, other paintings around the same time, the life of Leonardo da Vinci, the number of people that go and see it. Every view, every way of thinking about the painting, the Mona Lisa, gives you another way of thinking about that painting. And I think that's exactly what's happening in the human body. So every view we have of it is important, but it gives you a different kind of view. Each type of microscope gives you a different view of the body. Nothing can tell you the whole of it, right? Every instrument gives you a part of the whole.
Yeah, that's fascinating. So there's a question here from Marcel, who was asking when we were talking about the actin opening drug, did we actually find out how it worked? And did it happen by chance, or has the effect been understood and predicted?
We don't totally understand exactly how it works, but a good colleague of mine, Jordan Orange, and Emily Mace in Columbia University in New York, do work on that in more detail. So we do understand something about how that happens, which kinds of proteins are important in the way that opens up. Alex Caress is another person who's involved in that work, and so, I mean, that's how kind of science works. That, I mean, some things that we've discovered, we've dig into details, and some for many, many years, and other things we've discovered, and other people do some of the detailed work. So there's a community of people that investigate different aspects of this, and we haven't yet fully understood how it works, but other teams around the world are considering these things.
And that often happens in therapeutic drugs, doesn't it? I mean, I know famously the story of Viagra, that it was a heart medicine that they were putting in clinical trials, and they noticed it had this particular effect on men who were in the trial, and then they just sort of remarketed it as a cure for impotence. So that does happen quite a bit, doesn't it? Where you have a drug for one thing, or you think it's going to do one thing, but you don't quite know how it's doing it, or you sort of have the compound first and then work backwards to work out what its effects might be and the mechanism that it acts.
Yes, I think that's actually a very important part of how science works, that serendipity plays its role, but it's still true that none of these things come about entirely by just luck or chance. It still requires the prepared mind, as Pasteur said.
Okay, so we'll jump into some more questions. Obviously, there's quite a few SARS questions coming up, as you mentioned, SARS-CoV-2. So, for example, does Ziegler's work shed any light on the neural damage caused by SARS-CoV-2, e.g., anosmia, delirium, etc.?
That's a great question. I don't know the exact answer. It's not something I work on specifically myself. I'm much more familiar with the research that's gone into studying how the virus affects the state of the immune system, and there, what I do know is that it's very complicated, and so at the moment there are lots and lots of published papers show you, for example, that these particular cells are very important in the lung, or this particular type of an inflammation is very important in correlating with, say, the worst end of the spectrum of symptoms that you may or may not have. And so correlations are emerging between the immune system and what happens in the course of the disease. But there's not an exquisitely detailed level of understanding about how all that plays out, as far as I know. And so my guess, in the answer to your question, would be that with the neuronal effects that the virus has, we're probably at a similar state, but it's not what I work on, so I don't know for sure. But it isn't that we're at the level where there's a crystal clear understanding of how this plays out. Would be my guess of that.
So Gemma's got a question where she asks, what's going on with the rise in prevalence of autoimmune conditions? So it seems like autoimmune diseases are on the rise. Is it just because we're diagnosing them better, or do you think there is something environmental maybe that's causing this?
Yeah, so obviously that's a great question. And the short answer is we don't know. But what I do think is that autoimmunity is one of the areas where we are going to see huge advances. It's hard to predict the future, of course, but I do think that is an area of science and disease where a lot more can open up over the coming years. But I think, in reality, something like autoimmunity is a relatively recently discovered phenomena. I mean, it's not obvious that you would think of a person's immune system being able to attack themselves. That had to be discovered, and that was relatively recent compared to discoveries of germs, right, that cause disease and even cancer. So our understanding of the symptoms of autoimmune diseases is fairly well understood in the sense that there's an inflammation or an inflammatory immune response that you don't want, and that has led to some treatments for some kinds of autoimmune disease that involve dampening down that inflammation. For example, blocking one of the key messengers that immune cells tell to each other, called TNF, and blocking that, anti-TNF, stops immune cells sort of egging each other on, and that then dampens the inflammation in rheumatoid arthritis, for example. So we do have an understanding of the symptoms, and we do have ways to tackle that, but very often we don't understand the kind of triggering event, because by the time someone with an autoimmune disease goes to their doctor, they've already had the symptoms for some time, and or the thing that's gone wrong in their immune system has already existed for some time. So the triggering event is very hard to pinpoint. But I do think this is an area where we will progress in the coming years.
There's another question here from Marcel, who asks, it's obviously, he says, it's amazing what the body can do to protect itself and how we came to understand the process and use drugs to support it. However, have any studies been done on how we can boost our immune system without drugs? Now, often you'll see on, I don't know, herbal tea or various other marketing things that they'll slap immune boosting all over it. But is there any kind of science behind, vitamins or minerals or anything that is actually kind of immune boosting, or is it just, eat healthily, do exercise, the normal good healthy life advice? So
obviously that I think that things that you're talking about in terms of food supplements, it's very they're not, if you buy a yogurt drink that says it's going to boost your immune system, that hasn't been through a clinical trial. It's not regulated in the same way that a medicine is. So I think that's the first thing to bear in mind. Something like vitamin D has been shown to have beneficial effects, but many other things are much less clear. And that's really because it's very, very difficult to do the experiments. You can't easily give people a type of food to eat in a sort of double blind way, so that they don't know what food they're eating, for example, and then give them a sort of lethal dose of some virus and see what happens. So it's very, very hard to do the experiments, actually. And I have written about that in some detail, actually, in my previous book, where, you know, the only, you can get different answers from different scientists about this sort of question. The only thing that I think most scientists really agree on is that stress does correlate with a dampening of your immune system. And there's even some sort of mechanistic molecular understanding of that. And that's because when you're stressed, your cortisol levels in your blood increase. And so cortisol is a hormone that prepares your body for a change of state. And so it goes up, for example, when you're just before you wake up, to change your body to get ready for waking up. And it also goes up when you're stressed as part of this flight or fight response to get you ready to do something, fight or flight. And when cortisol levels go up, then that quietens down your immune system. And it's not really clear, you know, in a holistic way how that all works, but probably, you know, your immune system activity isn't that important when you're about to do this flight or fight thing. So the energy use of your body is changed. The immune system takes a back seat for a bit. And so if you're chronically stressed, then your immune system might be a little bit weakened over some period of time. But although most scientists would agree on that stress can impact the immune response, it's very, very hard to prove whether things that combat stress actually boost your immune system. That is very hard to do. And so in my book, I've talked about, for example, how whether doing Tai Chi, which might, or mindfulness, which might calm against stress, does that boost your immune response? And it's just very hard to do the experiment, because you can't take people that do Tai Chi versus people that don't, because there'll already be things about people that do Tai Chi that are very different from those that don't, that to any number of other things would correlate with people that do Tai Chi versus people that don't. So you can't, and so you can't take people that do Tai Chi, you can't even take a group and say, you know, you do Tai Chi and you don't. Well, what you'd have to do is say you do Tai Chi and you bunch of people do something that's a bit like Tai Chi but isn't Tai Chi.
SIBO Tai Chi.
Sort of have similar social contact, and then you'd have to give them the injection of something to see how they did in an infection. It's really, really hard to do. The only slight version of, only weak version of that experiment you can do is give them a vaccine, and then you could see how well do they make antibodies against that vaccine. But even if people make a bit more antibody in one situation or another, you don't know whether that's relevant. You don't know whether making a bit more of the antibody was actually really beneficial to them in actually fighting off an infection. So the bottom line is, that was a long answer, I'm sorry. The bottom line is it's very, very hard to know. But actually, that's one of the reasons I wrote the book, wrote all the 3 books I've written, is that it's really important, I feel, to discuss this and to understand it, because like you say, we are bombarded. If I go on the London Underground, I will see any number of adverts telling me how to boost my immune system. And it's really hard to think, well, what have you done to prove that, right? And so you have to be exposed to, I think, scientists talking about the types of experiments and why they're hard to do, so that you can come to. So my job as a scientist, I feel, is not to tell you what to do. I'm not telling you eat more yogurt, eat less yogurt, but I want everyone to sort of think about it, and at least I can tell you how experiments are done, why they're hard, why the results, why it's not clear, why we don't know the answers, and then you and other people make up your own mind about what's good for you to do.
Yeah, I think that's really important. As you say, it's the discussing. Well, why is it that do we not know this? Oh, well, actually, if you think about it, it's really, really hard to do the experiment. So yeah, I think that's a really, what's the word? It's a really useful thing to discuss with people, because it not only does it inform people, it also sort of engages them with the scientific method and sort of makes people think a bit about how we can know what we know. Ooh, there's a a few people. So Gemma says I was going to say this as well, actually, Gemma. They always use really clever language. If you've ever noticed, to get it past the Advertising Standards Authority, they always use things like supports immune health or helps to, support the body in whatever. And so they use very clear language that very much suggests like it's a medicine, but doesn't actually make any medical claims. There are a few people asking questions a bit more about the microbiome, actually. And Ranjit says, will we get to a point where we can naturally change our gut microbiome to control our health? And obviously, depending on what we eat, I guess that would have an effect. But I do know that there are some experiments where you literally will get a stool sample from somebody else that's, got a great microbiome that you can kind of, put into your immune system, or indeed into your digestive system via the sort of back entrance. So I wonder, do you think that would start to become more widespread and we might start to be able to buy these kind of things in shops or be prescribed them by our doctors?
Well, there were several questions within that. So certainly I think the direction of travel is that we will understand more about the microbiome and it will lead to new medicines. In terms of what you're talking about, Martin, as a fecal transplant.
That's the phrase I was looking for.
Which is as graphic as you made it seem. We have to be very careful about that because there are online ways of doing that in your own home and it can be quite dangerous. So I wouldn't recommend anyone taking that as something they should do off their own bat. And I think that there's only one particular type of infection that's really been proven to work for, but it does indeed work for treating a C. diff infection, and it can be a life-saving thing, but it has to be done in a professional way. And I think that we're on the cusp of understanding in detail what that really means. And in time, one of the things I write about in the book is how I think that this has to become sort of more professionalized in the same way that we have at the moment blood banks and blood transfusions are done. Then something as complicated as a microbiome transfer would have to require something like that has to come more from a depth of understanding and is done in a more systematic way than we currently are able to do. So the science, that's why I think that we're on the cusp of so much of a revolutionary time, because it's all kicking off. It's opening up now. We are just now glimpsing that the microbiome is so important, and it's, we're just working out the fundamentals that not tomorrow, but in the decades to come are unquestionably going to change how we live.
Oh, and that's a fantastic point, I think, with which to end on. Just before I finally say goodbye, just like to say thank you to absolutely everyone in the chat for all the brilliant questions. Sorry, I didn't quite get around to answering all of them. Just before we go, Dan, obviously I would strongly advise everyone to go out and buy their copy of The Secret Body. And also while you're there, in the bookshop, you might as well buy The Beautiful Cure if you haven't bought it already. But just before we go, is there anything else you'd like to say? Any people like to find you on the internet? Are you on Twitter or anything else? Do you have a homepage?
Oh, thanks, man. I do have a Twitter. It's at Dan Davis 101. 101 because there's a whole bunch of other Dan Davises. Dan Davis 1, Dan Davis 2, they've all gone. So I had to go for Dan Davis 101. And I think, I love the RI. I've been to it many times. I can't wait till we're really all back there. I am a member myself, and I think it's really important that science becomes more and more part of culture, which is essentially what you and Martin and the RI is on a mission to do. But right now there's been a swell of scientists on TV and on radio because we've needed to know about how to tackle the current pandemic. But I really hope that doesn't diminish as we go forward into live our lives in perhaps a more normal way. In fact, I hope it expands even more. And I would love the RI and all these other kind of public facing institutes to do even more, and hopefully, we can together think about science, because there's so much that we need to be talking about. Thanks.
Oh, I couldn't have said it any better myself. And thank you so much, Daniel. And thanks to everyone for watching. Take care and enjoy the second half of Italy, Spain. And good night.